And the talk is called Privacy and Security in the Age of Transparency with Zero-Knowledge Technology. She informed me that she'll mostly be talking about how DAOs can leverage zero-knowledge proofs. So give a huge round of applause to Marlene Ronstedt.
Thank you. Thanks.
All right. Hi, everyone. Nice to see so many faces. Just a little disclaimer, I'm really jet-lagged, so please bear with me. So today I would like to talk about how to bring back the autonomous into DAOs via zero-knowledge proofs. So you probably all know what DAO stands for, but let's just recall that one more time again. It stands for Decentralized Autonomous Organization. And the decentralization part usually in DAOs is really very well defined, right? Like a lot of projects that are leveraging DAOs or that are utilizing DAOs to organize themselves are globally decentralized. The teams are decentralized. They're using different voting mechanisms to decentralize how things within the DAO are being governed. But when it comes to the actual execution of the tasks, then we do not see so much automation as the autonomous in DAOs would maybe suggest. By the way, the clicker is not working. It's this one. OK, great. Perfect. Yeah, because decentralized autonomous organizations are not autonomous. And the reason for that is because automation is actually really, really hard. And the kind of current automation tooling that we have available is kind of limiting then what is actually possible and kind of tempers with security for some reasons, because it is off-chain and it's not on-chain, so it doesn't have the same security parameters. So the reason why we can't do all of these things on-chain is because of the Ethereum EVM, right? So everything on-chain runs in Solidity code, and it has to run in the EVM, and thereby smart contracts, even though they're being called smart, are actually not really that smart. So you can't really do that much on-chain directly. And therefore, DAOs are basically favoring decentralization over their automation needs. And for example, if a vote is being casted, then the execution of that vote actually still has to be executed by humans. So in a lot of cases, if you vote on Snapshot or something like this, then the result is being determined there, and it's all done on chain, and it's done in a wonderful decentralized way. But then when it comes to like making that result actually happen, we still need like a bunch of people, for example, signing on like a wallet together, or someone who eventually like moves funds from A to B or just pulls the trigger on something. So the automation part is currently not really happening to the level that we might want to see that actually. And I think also for me personally, one of the reasons why I got really fascinated back in the days by like the crypto space and the DAO landscape in general was really that thought that we're going to have these decentralized autonomous organizations that are these free agents moving through the internet, and that there are basically independent companies. But that's actually not really what there are right now. So if we take a quick look at like how automation is currently done, in the crypto landscape, we have like a lot of different automation services. I think like the most prominent ones are probably Gelato, then we have Chainlink automation, and we also have Keeper Network. And the problem, so to say, with the existing solutions for that is that their security model is very often staking based. So that means in order to run an automation off-chain, you have to put down a stake, and maybe you also put your reputation on stake, and maybe you can kind of generate like a higher reputation score by continuously providing services to that automation network. But that doesn't really, it's not really on par with the same security level we would have on Ethereum. So the problem is, if the automations that we're running off-chain are really mission critical, then it's really hard for us to say, all right, we're just going to trust someone who put down a stake of, I don't know, let's say like the equivalent of like 10K USD, even though the operation is much more costly, or the failure would be much more costly in that case. So just to go through some examples, what automation is being used for today in some DAOs. So I think the prominent one is obviously like MakerDAO in that case, but we also have, for example, like one really funny example I found, which I think is really cute, which is from where gelato is being used for Avegotchi NFTs that are being petted every 12 hours, and that is all done automatically. Some other use cases are more in the DeFi space, where, for example, PancakeSwap or Curve are using Gelato as well for handling tasks such as managing lending periods or setting limit orders or distributing yield rewards. And that can all be distributed in an autonomous fashion, but as said before, it's not really done in the same way as the security that the Ethereum environment would provide us with, but it's this more centralized factor that suddenly comes in by doing the automation off-chain. Equally, for example, with Chainlink automation, there is KeeperDAO, which is basically allowing you to run your own Keeper bots. And then, of course, there is Keeper Network, which is also sort of a decentralized collective of different people who put down a certain stake, and then they will build a bot for you, for example, a Keeper bot or an arbitrage bot, and then you can run that, or they will run that for you, and you kind of blindly trust them that they will do their best work. And sure, they put down the stake, but I don't think that's actually enough to guarantee for certain security levels, which we might want to have. All right, so I think one really interesting example here would be, for example, MakerDAO. So as you probably all know, MakerDAO is the DAO that is issuing the stablecoin DAI. And DAI is basically a basket of currencies that consists out of USDC, ETH, and I believe also Bitcoin. And basically, the idea here is that we constantly need to know the price of all these currencies to be able, that DAI is always $1. And we don't want it to depeg or anything like that, right? So we need to keep an eye on like what the price situation is like. And therefore, we need an oracle, and we need to automate that process because we can't do that manually, and we cannot do it with smart contracts either. So therefore, MakerDAO has like a rotation of 4 different services that automate looking at like what the prices are currently for these given currencies inside that currency basket. And the reason why they have 4 different oracles that they're using instead of 1 oracle is once again because of that trust assumption. We cannot trust the off-chain computation because the staking or the stake that is being put down for guaranteeing the security for that off-chain data is just not high enough. And in that case, the stakes for MakerDAO are much higher, right? Because if DAI would suddenly depeg, that would mean like $1 million, if not $1 billion losses potentially. So therefore, they have this rotation of 4 different oracles, which is a little bit more of a hack than an actual solution, right? Because we do not have that fully trustless environment that we usually want to have in crypto. So how can zero-knowledge proofs now solve this problem? So they have 2 major capabilities here. They give us a security guarantee, and they allow us also to do the scaling of the computation off-chain. So you probably have heard of like how ZKPs can be used for scaling Ethereum's transactions. So we have all kinds of different ZK rollups, for example, ZK Sync, for instance, where zero-knowledge proofs are used to scale transactions. But we can equally use zero-knowledge proofs for scaling computation that is happening off-chain in a sort of similar VM environment as on-chain. But in that case, what we're using for the example here would be actually a VM that is running in WASM instead of in Solidity. So therefore, we have a lot more different possibilities of what we can actually do off-chain. And basically, zero-knowledge proofs are giving us a guarantee to do these computations off-chain in a secure and also scalable way. And in addition to that, we can also, at least in some cases, because we're doing these computations off-chain, we can kind of hide what kind of computation we're actually doing. So if you, for example, create a trading bot or something like this, you could hide your trading strategy inside that ZK VM, and no one would actually have access to like what exactly is happening inside that VM. And you could have a DAO that maybe manages that bot, but no, and even though it would be all fully running autonomously on chain, nobody would actually see what is going on, so to say, behind the scenes of that. So how can we actually do that? And now I wish I would have one of my more technically minded colleagues on my side, but anyways, I'm going to try and explain it. So at HyperOracle, we have developed recently a new application which is called ZK Graph, and we're about to launch an application that is called ZK Studio, where you can build basically your own sort of variation of a subgraph, and you can use that to index Ethereum smart contracts. But instead of indexing it in sort of the traditional way of what we're doing so far in Web3, we're doing this with using zero-knowledge proofs. So what we're doing is we create a zero-knowledge proof of the Ethereum block headers. And by pulling the data, or by creating the zero-knowledge proofs of the block header, we can instantly verify if the data that we're receiving from the chain is actually correct or not. Whereas in the existing use cases, for example, with a subgraph, you just have to trust that the data that you're getting from the chain is correct. And in this case, you just verify it, and you're like, OK, instantly, within like milliseconds, you're like, cool, this data is actually correct. So then what you can do is basically you can write your own smart contract where you define a certain custom logic for your automation. You put that smart contract on chain. You then index it using the ZK graph. And then you can kind of run that automation off-chain in a ZK VM environment, which is the VM I have previously mentioned, which we are developing together with Delphinus Labs, which is the ZK WASM VM. And inside there, you run your automation. And then once you have run the automation, you create another proof of that automation. You can then put that proof back on chain, verify it against what you have originally put on chain, so you know, all right, this has done all the things I wanted it to do. And then you can use that to then trigger the automation services or the automation that you want to happen on chain. And basically, the big advantage here in comparison to existing solutions is that, well, you can verify that the data is correct, and you can also verify that the process that you wanted it to do is actually also eventually being executed. Whereas in other scenarios, you would really just have to trust the system itself and the stake that has been put down. So what are some potential use cases for that? So I've been speaking a lot about like MakerDAO, and about DeFi applications, so loans and lending is one application for that. Obviously also treasury management, but you could also create a DAO that runs its own arbitrage market maker, for instance. Or you could just use it for task execution, because you're accessing this ZK WASM environment, and that really opens up like a lot of different new possibilities. So you could like, I don't know, you could actually, I know it's a bit of a hype word, but you could do like some AI processes off-chain, and then put that result the AI has executed back on chain, and then trigger new actions within the smart contract environment on chain. So I think that would really open the doors for DAOs to really have a much more, well, yeah, autonomous way of operating. And then, as mentioned before, it can also be used for privacy tooling. So, for instance, if you want to run your own market maker or something like that, and you don't want to reveal your trading strategy for that, you can have that inside the WASM VM. Nobody will see what's going on inside there, and therefore you can increase your privacy for that. You could potentially also use it for example, to prove your ownership or to prove your solvency. To be honest, I cannot specifically explain how you would exactly do that, but I could connect you to my colleagues who could do that. But yeah, basically you could use it for that as well in the privacy realm of things. And yeah, as a conclusion, I think we can say that basically zero-knowledge proofs can really be used to make more DAOs a lot more autonomous than they are right now, and also slightly more private. And I think the off-chain computation tools that we have right now, like the ones I mentioned before, like Gelato, Chainlink, and Keeper Network, are great for certain smaller tasks. But if we want to run like a really proper operation where everything is being decentralized, then it's a lot harder if we can actually not trust that system that we're running our automations on. So therefore, we want to kind of offer people a fully trustless system that is fully permissionless, and where they can basically just do whatever they want without being limited by Solidity code. So yeah, and I think another nice feature, as mentioned, is also the fact that it enhances privacy also to some extent. So this QR code is basically just leading you to our website if you want to check this out, if you want to play around with it. We already have a small MVP on our website right now, but there is going to be more coming in the next couple of weeks where you can really start developing your own ZK graphs and start running your own automations. Thank you very much, and let me know if you have any questions. Thanks.